Okay, so this optimization we can see is still running. I don't want this to take all day long because I'm going to run a couple other optimizations as part of this. So I'm going to manually stop this when it hits to 10 minutes. Um, it's also good to know that you can manually stop these optimizations when they're running. So if you go here in the top left, you'll see this little square, just like stopping on a movie or what have you. And then when this hits 10 or close enough to 10, which is probably about now, if you go ahead and hit stop, um, it'll say, hey, do you want to accept the results of optimizing this particular config? If you say no, it basically resets everything to what it was when it started. In that case, it would go back to looking like the graph beforehand. But we want to go ahead and accept it. We think this is pretty good. So we're going to say yes. So now we have an optimized config, and those are pretty darn good results, right? I think one of the biggest things to remember about MSO is that we're not just optimizing the main listening position, and that's really the biggest value that MSO brings. When I first got started in this, I think like most folks, I was using REW, and REW and that optimization method and doing your EQ over there and just preing that into the Minute DSP is really, really good if you've only got one listening position. And frankly, MSO probably is not appropriate if you only have a single listening position. Just use the REW method that everybody's been using for quite a while and everybody talks about. But what's really interesting and really powerful with MSO is that we're also optimizing our non-main listening position. So we can see here that we've got really good response at all of our listening positions compared to our before graph, right? Um, so this is pretty nice. We can see that there's some stuff that we don't really like. I typically focus pretty heavily on the crossover region and performance in the crossover region when I look at these graphs. That crossover region is going to vary for folks, but I would say that the most common range is probably anywhere from 50 to maybe 110 or 120 hertz, just depending on what your main speakers are and maybe what your satellites are and how low they can play. So if I look at that particular area, I can see here between 50 and 60 hertz. We've still got some pretty big deviations in our non main listening position seats. Remember, we optimized for 75 dB, but we're offset by 10. So the target line for this is 65 dB. And if we look at that, we've still got some bigger dips than I would really like to see. Remember, I said earlier, plus or minus 5 dB is really a great target for us. And we're kind of outside that, right? We're about right at 5 dB, maybe a hair below for the left position, and we're getting close to 7 decibels down in the right position, which I don't really like. Um, but overall, this is really, really good. So the next question becomes, well, what should I look at changing to make this optimization look even better? Um, how do I clean this particular area up? Or some of your optimizations might show some really weird stuff starting to happen. Maybe you only optimize up to 100 hertz, but right after 100 hertz, things really go haywire. In my room, things kind of trail off. Frankly, they trail off pretty nicely going up to that 200 hertz range. So I'm not really concerned about that. Um, but maybe you have a big null that shows up, or some weird, just really weird divergent behavior that's a little bit too close to your crossover range. So let's look at some options for kind of fiddling with this and improving the way that this looks. So to do that, we don't want to change the current config that we have. We want to operate on a new config. Remember, a configuration is basically an experiment that you're going to run to see what to see what looks best in your room. So the first thing we want to do is, if we kind of minimize this on the left hand side, again, we're in the config view, and we've got this 75 dB config that we just ran. So what I want to do is I want to run with the same exact parameters for the most part. But we're going to experiment by adding a couple of additional PEQ filters to see if we can shore this up, okay? So the easiest thing to do is right-click on this config that we just ran, and let's clone this configuration into a new one. We're going to call this, let's call this 75 dB. We're still going to optimize from 15 to 160 hertz, but maybe this time let's go with, I don't know, let's say 8 PEQ filters. All right, so that's why I'm going to call this 75 dB, which is my target. That's my optimization range, and then we're just going to say, hey, this is going to be 8 PEQ filters. We're going to go ahead and clone any associated graphs. So let's say okay. You can see I've now got a config that's called 8 PEQ filters, right? So let's go back to our data view, because the first thing we need to do is clean up graphs, and we need to get something that we can actually look at while this thing is running. So we can see I've got my baseline listening positions, my original listening positions, my before and after, and now I have two additional graphs. I've got a listening positions graph and I've got a before and after graph. So let's rename this one here. So we'll rename this one. This is going to be my 8 PEQ listening positions. And then this one, we're going to end up using this one to compare all three of them together. So I'm going to rename this one, and I'm going to call this base verse 5 PEQ verse 8 PEQ. So this graph we're going to use to show all of our different charts, all of our different traces all in the same graph. So we've renamed them here, so that'll get the tabs for us. But now what we need to do is we need to change the names on the graphs themselves. So if you right click on a graph and go to graph properties, this is going to be the 8 PEQ. So let's change that to 8. That's the only thing that we need to change. And on this one, we're going to right click graph properties. We're going to change a couple of different things. The first thing that we're going to do is we're going to change this to the base verse 5 PEQ verse 8 PEQ. That's going to change our title that shows up here where it says before and after right now. So we'll go ahead and we'll say apply. The next thing we need to do is we need to make sure that we have all of our data. So if we go down to data and we go to measurement groups, by default, it keeps the baseline and then it adds our 8 PEQ, our 8 PEQ of adds. It basically changes from the original config to the new config, okay? This can get a little bit confusing, so let me show you the way that I personally do this to keep me sane when I'm working with all of these graphs. We're not going to change anything here just yet. The first thing that we're going to do is we're going to go over to our new graph, and let's go ahead and show this graph. And this graph is going to look the same as our other graph, okay? What we want to do is make sure that we've got all of our traces still named the correct names. The problem we've got is these names aren't going to match what our new config is called. Remember, our new config is called 8 PEQ. And if I expand this 5 PEQ, notice it's actually referring to the 8 PEQ config group that we have. So I want to go ahead and rename these to the 8 PEQ. So if we right click, rename it, let's just change that to an 8. Right click, rename it. We'll change that to an 8. Right click, rename it. And we'll change this guy to an 8. So this is now going to show our before and after for baseline and 8 PEQ. Now what we want to do is we want to add in our 5 PEQ results. So if I go back to the top of this particular graph, right click on it, graph properties, data, measurement groups, let's go ahead and select the 5 PEQ as well. So we'll go ahead and hit apply and say okay. And notice we've got a 5 PEQ graph in there. Now, why did that pop up here instead of down here at the bottom or up here at the top? That's our 5 PEQ measurement. Remember, we optimized to a 75 dB target level. That is the optimization at the 75 dB target level. That's not configured to have any offset. The offset followed our original 8PEQ or the new 8PEQ when we cloned the graph. So that's actually okay. Okay. We can still run this, we can rerun this using the same settings, and we don't have to go and mess with the data offset for these new traces that we're displaying. But what we do need to change is, again, notice down here at the bottom in the legend, it's measurement group trace 7, 8, and 9. We want to change those and make those meaningful. So let's go in here. We did this earlier. We're going to select our measurement trace. We're going to say rename, and this is our 5 PEQ left. This will be our 5 PEQ MLP, if I can learn how to type. And this last one's going to be our 5 PEQ right. So now my legend matches the data that is actually shown on the graph here. So what do we need to do now? Well, part of the problem that we have, as you can see, is that our new 8 PEQ data here down at the bottom has already been optimized, and that's a problem. So when we go to our config view, what does it mean to why does it show as already optimized? Well, when we cloned this, not only did we clone the data that it was traced, but we actually cloned after our optimization was run. So we cloned with all of the parametric EQ, gain, and delay settings that were associated with this. So if I go into my 5 PEQ and I select one of these filters, so I'm just going to go to this left front sub and I'm going to select this first FL1 filter. You notice on the right hand side, we can see the properties of this filter. So this is a PEQ filter. PEQs have 3 values. They have the center frequency, which is the midpoint of where the filter is going to take effect. They have a boost value. Boost is a little bit of a misnomer. It's actually a gain. And the gain can be a positive or a negative value to represent a cut. Here we can see that this has a value, a cut of minus 9.8 dB at this center frequency value of 127.9 hertz. Okay. The last parameter a PEQ has is the Q, which is essentially a measure of the bandwidth or how wide of an area of frequency that this particular PEQ impacts. So we can see it's got a Q of 8.3. If I flip back to my 8 PEQ and I look at the same exact filter, it's got the same exact values, okay? We don't want to optimize something that's already been optimized. Fortunately, MSO gives us a nice clean way to reset everything so that we can have another go at it. So if I right click on this, down at the bottom, near the bottom, there's a reset all filter parameter values. If we go ahead and click on that, it says, hey, you're going to reset everything. You sure you want to do it? I can't undo it. Say yes. We're going to see this bottom one snap and now match all of our originals. And again, this one has that offset in it. That's why it appears down kind of low. So that when we optimize for 75, it'll actually end up settling down here around that 65 because it has that minus 10 dB offset that we had earlier. So now what we need to do is we actually need to tell it, hey, we've got more, I want you to use more PEQ filters. So what we need to do is we need to add some filters to each one of our output channels so that MSO can use those to run the optimization. When we initially did our import, we said use 5. So the easiest way to add 3 more is to select one of these. We can right click on it. We can say copy. And then if we select the filters folder, we can actually, right click and we can paste. If you're a keyboard person, you can use Control V. I'll do it with the GUI the first time. Control V, paste, paste. So I've now pasted 3 additional PEQ filters. So now I have a total of 8 for my left front sub. I need the same thing for all my other subs. So I'm just going to use the keyboard shortcut since that's a little bit faster. And I'm going to paste 3 more for each one of my other subs. There's 1, 2, 3. 1, 2, 3. Whoops, got to select filters. 1, 2, 3. 1, 2, 3. So now I have 8 PEQs for each of my subfilters, plus my gain blocks, plus my delay blocks. Now, if you remember correctly, we set some options to restrict our PEQs to make sure that we're not going to overcut, to make sure that they're centered and things of that nature. So what we want to do is we want to double check and make sure that those things are all still set correctly. So if I click on my 8 PEQ config, optimization options, I can double check everything before I run it. Hey, 75 dB, 15 to 160. I'm going to change this to 10 minutes. 20 was too long because, like I said, I don't want to spend all day doing this. You can make that whatever you want it to be. Our parameter limits, everything is still 15 to 160. That max cut is still 30. Boost is still 0. If I go to my constraints, it's still 31. We're good to go. We're ready to run this optimization. So I'm going to go ahead and run this optimization, and we'll see what kind of results we get. So if we right click optimize config on our 8 PEQ, there we go. We're off to the races, and we get to see nice, fun dancing lines as this thing goes off and figures itself out. I'll pause the recording, and we'll come back here in about 10 minutes. All right, so that ran for about 10 minutes, exactly 10 minutes actually, and we're done. So we're going to go ahead and we're going to accept the results of this one. We're going to say yes. We're going to take a look at what happened. So, all right, so if I look at this graph, again, we're eyeballing things right now. I'll show you how to get some real data and get really, really detailed on which one is better. But if we can look at this, like they're pretty similar, you know, from 15 hertz up to about 50 hertz. You know, just eyeballing it, the 8 PEQs looks a little bit better down flat, or a little bit better flat, excuse me, looks a little better down low, a little bit flatter, a little bit smoother response in all the listening positions. But critically, you know, that area that we were kind of concerned about between 50 and 60 hertz, I mean, it looks a lot better. We've still got a little bit of deviation here, but remember our scale here is 2 dB. We're centered on 65 dB. So we're pretty much plus or minus 3 dB through this area where we're getting some 5 and 7 dB dips. Now where this particular optimization gets a little bit more wonky is a little bit higher. We can see that we've got a little bit more of a deviation, you know, probably up in the 120-ish hertz range. We've got a little bit more, you know, few more swings out here maybe than we had compared to the previous one. But again, looking at that 65 dB level that we were targeting, we're still pretty much plus or minus 3 dB through this whole region. So overall, it's a lot better result. So I personally, you know, maybe I'm happy with this, maybe I'm not. So I mentioned earlier, you know, we walked through an example of how to add additional PEQs. The Mini DSP 2x4 HD has up to 10 PEQs, so I could go in and add 2 more PEQs per output filter if I wanted to really play with that and see if that really bought me anything. Some other things to consider as you try to run additional optimizations and get a nice even sub response is, again, I mentioned you can change that target curve. Maybe you try it a little bit higher. Some of these things, these dips that we have here, are products of just natural cancellation from unaligned subs. So the delays are going to fix some of these things naturally. So even though, you know, 75 dB came in below all the big dips, maybe 80 dB is a better target for this. Maybe even 85 dB, just kind of picking some numbers out that are nice and round numbers that you might want to experiment with. One of the other things that we did not get into in this either is you can add, there's this concept of shared filters in MSO, and a shared filter is a filter or a PEQ that goes on the input side of your mini DSP. So you can actually add input filters and use those to also help flatten out your overall sub response. There's some pretty interesting results that you get when you add those input filters that actually can help you get a really, really flat response if that's just something that you're after. Depending on your use case, you may or may not want to do that. Like personally, I use base EQ or BEQ as most people call us. I don't like to have any filters on the input side of my DSP. I haven't gotten into BEQ Designer and merging my own settings with BEQ. I avoid that myself. Another reason I avoid that is because, frankly, I've gotten really, really good results in my room just using the output side filters and output side gains and delays. So we'll jump into next is how do you really quantitatively look at the differences, because you're going to end up in a situation where you just can't eyeball it. They're so close, you can't tell which one's better, which one's worse. So next we're going to drop into the performance metrics and take a look at how we can actually look at some hard numbers to compare a couple of these different configs.